So your guys' job is to make sure that when my class starts, I'm recording. Because I'm terrible at remembering it. And I feel bad. That way we can see everybody. Okay, so we are back. We're doing things a little bit different just because I'm getting the feel that you guys would prefer like hard copy paper notes, right? At home, I feel like you would rather just have notes than like the Pear Deck thing, right? Maybe. You seem to be a little bit frozen. Look, so I did not upload a Pear Deck lesson. So those at home, all I did was upload the note PDF. That way you can open that and work with us, and you can stay in the Google Meet to see what we're doing. I'm going to share my screen as we're working. It might make it a little bit easier. I'm going to pass that out to everybody that's in here. But on your homework yesterday, you started talking about and looking at equations that had variables on both sides. Were they, for the most part, easy to solve? Yesterday's homework? It was a little bit confusing at first. And then we had to kind of figure out that workaround, which I was talking to some of us in study hall about what some of your classmates found, which was to figure out how to put a 0 in front of the x and get around it that way. But overall, they weren't too easy to solve. So today we are moving into learning how to solve two-step, multi-step equations where we have variables on both sides. So the first thing I want you to do is just look at that first problem. I'm going to share my screen in the Google Meet. But again, you can just open up that PDF. It's going to just be right with where we're doing. So when I share my screen, you're going to be able to see what we're doing. And then if you want to add in some answers or talk, you can unmute yourself in the Google Meet, whatever you want to do. But what we're doing right now is just look at question number 1. Naomi is researching websites that make custom stickers. Site A charges $5 per sheet of stickers plus a $4 setup fee. Site B charges $3 per sheet of stickers plus a $10 setup fee. For how many sheets of stickers is the total cost the same at both sites? So I just want you to think about that. Try to find the answer any way that you think you can. So I'm going to show you when I go over it how to write an algebraic expression and then use 2 of those to create this big clunky equation so that we're going to learn the method to solve it. But right now, you guys are pretty good with number sense and guess and check and things like that. So just try to find an answer to that problem. How many sheets of stickers is the total cost the same for both stores? So again, those that are just joining in the Google, there's not a Pear Deck, there's not a Nearpod. I just uploaded the notes, so you can open those and just work on them with us if you want to print them. And then write them. I'm sharing the screen in the Google Meet, so you'll see what we're doing. Seems overall, though, to work a little bit better than what we were doing before. So I see some of you writing an equation, which is fantastic, but then we're getting stumped on how to solve it. So when I go over this, I'm going to go through that process on how to solve an equation where you have x's on both sides. But some of you, I'm noticing on the problem, we're kind of just doing guess and check and making a table to figure out where those numbers are the same. So I'm really just trying to see if you can find the number, a little bit less algebra. both sides. It should be the same.
So
Both sides. You want the costs to be the same. So how many sheets are you gonna buy from each website? To make sure. Okay, so we seem to be a little stumped. Some of us are getting answers using guess and check. I see a lot of us, our reaction was to write an equation, which is impressive. So now we're just gonna go through how do you actually solve an equation like that. So Naomi is researching and she sees that site A charges $5 per sheet plus a $4 setup fee. So for site A, what can I write for my equation? Or what would my equation be? So $5 per sheet. Do I know how many sheets we bought? No, so what can I use if I don't know what that is?
using guess and check.
A variable, we can use guess and check, yeah. So I'm gonna say X equals the number of sheets. So then if it's $5 per sheet, I have 5X plus a $4 setup fee. So that would be my equation to model the first situation. $5 times how many sheets I have, and then it's just a $4 one-time fee, no matter how many I buy, I'm paying $4. So for site B, if it's $3 per sheet plus a $10 setup fee, what would my equation be? So
3x plus 10.
So $3 per sheet plus that $10 fee. So if I'm looking for the prices to be the same, these equations represent the price. If I'm looking for them to be the same, what can I do with both of my equations? What symbol means the same when we're talking about math?
Equal.
So I'm gonna set them equal to each other. And say site A has to be equal to site B. And I saw a lot of you get this far, but now we're stumped because we don't know how to solve this. This is some of the equations that you were looking at last night, and we don't have a process yet for how to solve that. So that's what we're getting into today. And some of you found the answer here using guess and check, but your answer was pretty low, right? If you had to keep guessing for 10, 20, 30 different things, nobody wants to sit here and guess and check that long. If we have an equation where we have variables on both sides, your first step is to put all of the plain numbers onto one side and all of the variables onto the other side. So when we were solving equations, first thing we did was get rid of our plain numbers. So we're still gonna do that. How would I get rid of positive 4? Subtract it onto both sides. So I'm gonna do -4, -4. So then on my left-hand side, bring my 5x down, equal to, what I have on my right-hand side is 3x plus, what's 10 minus 4? 6. So once I move all of my constant terms, that's what those numbers are called, my constants to one side, I move my variable terms to the other side. So I want to take this 3x and shift it over here. So if it's positive 3x, what do I do to get rid of positive 3x? Not divide, because I'm not at that step yet. So I'm not trying to get rid of the 3, I'm just trying to take this whole piece and move it over. So if this is positive and I subtract it from the left-hand side, I also want to subtract it from my right-hand side. Because I'm just not at that step yet where I'm dividing. Okay, so then over on the right, do you remember combining like terms from last year? No. Okay, so if I have 5 letter X's and I take 3 of them away, how many are left? 2. So whenever you're combining like terms, you're really just subtracting the numbers. So I have 5, like if you think about like the magnetic letters that you use to hang on the fridge, if I have 5 of them showing up, I took 3 of them away, I'm left with 2. Equal to, if I had 3 X's and I took all 3 away, do I have any left on that side? Nope, so that goes away, and you're left with just your 6. So now it turns into what we were looking at yesterday, which is what Peyton was trying to do a 2 step too early, but what would you do here just to finish solving? Divide it. So then how many sheets do we get? Three.
This is like, wouldn't it be 6/1, cause it's just 6?
You can write it as 6/1. But all I'm doing is dividing by 2, so I can do 6 divided by 2 in my head. I don't need to turn things into fractions if there's no fractions in the problem.
I thought that was, you were writing that as a fraction, like 6/2.
Oh, I was dividing.
Okay.
So over here, Daniel, if I have 5 x's and I take 3 of them away, how many do you have left? 2. Okay, so this is the first problem that we've done. So if we're a little anxious and apprehensive, perfectly fine, we have a whole day to do this, okay? But your main idea is to put all of your plain numbers to one side, all of your variable terms to the other, and then start solving it like we were looking at last week.
If it was 3, would the first one be 13? I mean, the second one?
So 3 times 3 is what?
9.
Plus 10,
Um,
19. So some of you solved this using guess and check, and I saw the tables, which is okay because you only had to check maybe number 1, number 2, number 3. But what if it was like 25 sheets that made them equal? You would be sitting there forever trying to guess and check. So that's why we're using this algebra to go through and solve it. So plain numbers to one side, variable numbers to the other, and then we're gonna start solving them down. Take a look at the next one. A personal trainer charges a one-time fee of $60 plus $25 for each individual session. A fitness club charges a yearly fee of $450 plus $10 for each session. Write and solve an equation to determine for what number of sessions the cost will be the same. So it's really the same thing. Try to think about your 2 equations. Use what we just did to help you. Set them equal to each other, and then try to solve them. And then if you're at home too and you have questions, I have the Google Meet posted on my big board. So you can unmute yourself, you can type it into the chat. Something was happening yesterday and I couldn't hear my speaker, so I apologize that it was kind of messy. But my big loudspeaker is working now, so you will come in loud and clear. The one-time fee for $50 and $10 for each session. That's what you're getting this. The variables in the spot. A yearly fee of $450, and that's $10 for each session. So which of those numbers changes based off of how many sessions you have? $450 or $10? So I think with the variable next to 10.
10x.
So you're $450. That one was right, because it was, oh no, yeah, the $60 fee, $25 per session. So if we look at question 2, one-time fee of $60 plus $25 for each individual session. Which of those numbers changes per session? The 60 or the 25?
The 25.
Right. So that's the one that's gonna go with my variable, because in this case, if I have the letter X, X is going to represent the number of sessions. I don't know what that is yet. That's kind of what I'm looking for in the end. So for company A, I have a $60 fee plus $25 for however many sessions I have. Gym B, I have $450 as a yearly fee, and then $10 per session. So what would my equation look like for that?
450 plus 10x.
Because it's $10 for each session, X is the number of sessions, so I would do 10 times X, and then that 450 is just a one-time fee. So if I need them to be equal, set your equations equal to each other, 60 plus 25X equals 450 plus 10X. So then once we have that, we just have to think about how to solve it. So plain numbers to one side, variable numbers to the other. It doesn't really matter which ones you start moving first. I just always try to avoid negative numbers. So like I would not subtract 450. I would subtract 60 because it's smaller. But it doesn't really matter. So I'm going to get rid of my 60 from both sides. So then what is 450 minus 60? Okay. So I get 25x equal to 390. Then what am I going to do? Got my plain numbers on one side. I need to move my variable terms to the other side. Yep. So if I put my constant number over here, I need to unhook these from each other. So I want to move my 10x over to the other side. So if I subtract 10x from my right-hand side, I have to keep my equation balanced, so I also want to subtract it from my left-hand side. So I'd say minus 10x minus 10x. So I have 25 x's, I take 10 of them away, how many are left? 15. Yep. So now we're back to the simple one-step equation to finish it out. Divide by 15. What's 390 divided by 15? 26 sessions. I'm going to skip question 3 for right now, just because I don't know if we're super comfortable with these types of equations, so I don't want to throw those consecutive number problems in there. So just jump down to look at question 4, 5, and 6. No word problems, no setting anything up, straightforward solving, answer questions number 4, 5, and 6. Okay? I mean, it's up to you. I posted that just in case you would prefer to use the document, so I just gave you access to it, but if you're just using line paper, that's also fine.
We're actually thinking equal score, or just equal? Because in this one, we can do like minus 390, 25x equals 300.
So, you have it like right in your math, right underneath, so that it's a little bit easier. So then you would have negative 5kx, so write 5k. Equals, you didn't use that 3k yet. So then negative 6 minus 2, be careful, you're going forward. If I'm subtracting 2, I'm going 2 to the left. So if you're at negative 6 and you subtract 2, where are you gonna be?
Negative 8.
Mhm.
Okay, so I was just minus 6.
Minus 9 and negative number is something. Don't worry,
I thought it was like 3k subtracting positive 6.
which is the same as adding negative 6, right? You can think about it the same way. If it's a negative 6 or a minus 6, you can get negative 8. So you say minus 8. Negative 8 minus 8 is the same thing. This is making it easier so you can see where you're at. Yeah, when you're subtracting pair of like terms, you're taking a regular 2 away from something with a variable. So -2, -2 1 to your 6 on the k.
So if we mix and bring everything else down, bring down to 3K, like right in line with your negative 8. You didn't use your 3K yet. Right, or even you can rewrite what you just did.
Okay.
Okay, from here. -6 minus 2. -2. Minus it. So then you have to be -8 here, so you say -8.
If we subtracted inside, how would we do it?
So you don't see a number there, so what number would kind of be there? What's the only number that you can't see? That you're at? So just, so if you have 0, you subtract 2 from it.
So this do
Because this is +3. So how do you get rid of +3? Would you add 3 to it? Right. So we'll go over the number 4. So what should my first step be for number 4? I have 2, and it, again, you can kind of start wherever you want. You just are putting numbers to one side, variables to the other. So what can we do first here?
I added 6 to the sides.
That's what I would do too. Like I said, because when I'm doing things, I just try to avoid negative numbers everywhere I can. So if there's a negative number here, I'm gonna get rid of it by adding it. Some of you subtracted 2, that's fine. It doesn't mean you're doing it wrong, you're just going a different route. So I'm adding 6 to both sides. 2 plus 6 gives me 8 plus 5k equal to 3k. Be in the habit of writing your math right under what you're doing and then bringing down everything else that you haven't used yet. So now I need to shift my variables to the opposite side. So I need to unhook these. So if I have +5 here, how do I move it onto my other side? +5 means subtract. And again, some of you went about this a different way, but you're gonna see you still get the same answer. So then I didn't use my 8 yet, so I'm pulling that down. +5 and -5 cancel out. So now I have 3 k's, I take 5 of them away. How many do we have? Peyton?
-2.
So then my last step, divide and divide. So we get -4 is equal to k. What's that, Peyton?
When I got something different, but like, I did like this stuff out. I don't know about after that.
Match up your like terms. If you're taking -3 of k away, you wanna take it away from this. You took it away from your like number. Instead of saying minus the end of the 8, you want minus the end of your k. Looking at number 5. What do I do first? Or what can I do first? Couple different ways to start it.
You can add 6 to 2.
I can move the 6, but I'm gonna be careful, because this is a +6. So if I add 6 to +6, it's not gonna cancel it out.
So subtract.
So -6 and -6. Then I have 5a. -7a over here. So then what's 2 minus 6? I'm at 2, I subtract 6 backwards. Where do we end up? Side. Good. So now I'm gonna move my variables to the other side, and if you're stuck on where to go, just look at whatever has 2 terms in it. So I'm gonna move my 5a over, subtracting because it was positive. So then I have -4 is equal to -7 minus 5. So I'm at -7, I go backwards 5, we end up at -12. So then divide by -12 to finish it up. If you're left with a fraction answer, try not to write it as a decimal. What is -4 over -12? Right, so my negatives cancel out, and then I can divide 4 and 12 by 4 to get 1/3. You okay on that?
Miss Landon,
Yes, Carly.
where did you get -12?
Hold on, I'm trying to find my remote because the volume is really loud. So my -12, when I'm subtracting my 5a from both sides, I have -7, so I have -7 a's. I take 5 of them away, so if I'm at -7 and I subtract 5, I'm at -12. You see what I'm saying?
Yeah.
-7, take the 5 away, -12. And then I reduced to get 1/3. Any other questions?
Miss Landon,
Yeah, Rose.
I subtracted -7a from -7a and -7a from 5a. Can't you do that too?
Like I said, there's a couple different ways to do these problems. You don't have to start in the same place I do. Like I probably would take that -7 away first too, just because it's negative, and I would try to get rid of all of those. But you should end up in the right, did you get the right answer?
No, I got
So you wanna watch, because it's a -7a, so you don't wanna subtract that, you wanna add that as your first step. So you, okay, yeah.
I'm not getting -1.5.
That's the same thing I have to say to Rose. So this is -7. I don't subtract 7 to get rid of it, so it's the opposite of -7. So 5 plus 7 gives me 12.